Hello everyone. So in the last video we learnt about the first law of motion. In simple terms it says that if the acceleration of a body is zero, then the net external force acting on the body is also zero. Or if the net external force acting on a body is zero, then it means that the acceleration of the body is also zero. But the first law doesn't tell us the story after that. That is, if the force acting on a body is non-zero, then we know that it will have some acceleration. But how much? What magnitude of force will generate what magnitude of acceleration? This answer is not given by the first law. To answer this question, we need to understand the second law of motion. But we cannot directly jump to the second law without understanding the concept of momentum. So in this video, we will learn about the concept of momentum. Now to understand the idea of momentum, let me give you a situation. Suppose that there is a car which is at rest and I ask you to stand in front of it. Now you can do it without any trouble. What is so tough about it, right? But if I ask you to stand in front of a moving car, you will think twice about it because you know that it can cause you serious injuries. So what is so different about a moving car as compared to a car which is at rest? The answer is that a moving car has an ability to cause some impact in case of a collision. Now this ability is termed as momentum. So it is possible that the moving object does not collide with any other object, but it still carries some momentum with it, which can be felt only if it collides. We all understand the idea of momentum in our day-to-day life. We just don't use the term for it. So let me explain it to you with the help of an example. Suppose that you have to catch a plastic ball which is coming towards you. You can do it easily without any problem. But yes, if the ball is coming too fast, in that case, you will have some trouble in catching the ball. And the reason is that a fast-moving ball will have more impact on your palms than a slow-moving ball. Therefore, we can say that the velocity of a body directly affects the momentum of the body. And moving further, if the plastic ball is replaced by a metal ball, it will become quite troublesome to catch it. Even if this ball is traveling at a low velocity towards you, you will feel considerable impact on your hands. And the reason is that heavier objects have more momentum than lighter objects coming at the same velocity. So we can say that both mass as well as velocity directly affect the momentum of a body. So now it's time for some bookish things. Momentum is denoted by the small letter p, and it is defined as the product of mass and velocity for obvious reasons that we have just discussed. So we can write P equals to m times v. But we know that mass is a scalar quantity and velocity is a vector quantity. So their product will also be a vector quantity. And hence we must always write P vector equals m times v vector. So now we have a new physical quantity and that is momentum. So what are its units? Well, it is quite easy to derive. So the SI unit of mass is kg and the SI unit of velocity is meter per second. And hence, the SI unit of momentum becomes kg meter per second. So till now in this video, we have learned the concept of momentum and how to write it mathematically. Now, I would like to draw your attention to a very important point. And in order to explain this point, let's take the help of a situation. So think about a box which is resting on the ground. Now, the velocity of this box is clearly zero, and therefore, the momentum of this box, which is m into v, is also zero. Now, if I wish to change the momentum of this box, I must change its velocity, because certainly I cannot change its mass, right? To change its velocity means to provide it with some acceleration. And to provide it with some acceleration, we need a net external force. That's what we have learned from the first law of motion, isn't it? So it means that to change the momentum of a body, we need a net external force. We can also say that a net external force causes a change in momentum of a body. So a very common example to understand this statement is seen in the game of cricket. When a fielder catches a ball, at the beginning of the catch, the ball has some velocity and it also has some momentum. Let's say it is p. At the end of the catch, the final velocity of the ball becomes 0 and so does its momentum. So it means that the fielder applies some force through his palms on the ball. And as a result of this opposing force, the value of momentum changes from some finite value to 0. I am pretty sure that till now you have got the idea that all our discussions in this chapter are revolving around force. But the amazing thing is that we have not yet defined force in terms of mathematical quantities. For example, we have defined momentum as the product of mass and velocity. We have also learned that acceleration is dv by dt. We have also learned about velocity as dx by dt, but we have not yet defined force in terms of mathematical quantities. So now that we have learned the relationship between force and the change in momentum, we will be able to do it. But we will do that in the next video. So before we end this video, let us do a quick recap of whatever we have learned. Momentum is the ability of a moving object to cause an impact upon collision. Every moving object has some momentum. Even if the object doesn't undergo collision, it still carries some momentum with it. Momentum is defined as the product of mass and velocity. P vector equals m times v vector. The SI unit of momentum is kg meters per second. To change the momentum of a body, we require a net external force, or a net external force will cause a change in momentum of the body.